Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from continuity and differentiability of functions. And here in this session, we are going to discuss the continuity and differentiability of this function f of x, that is the product of two functions x cube and the signum function, that is signum of x. And we have to discuss the continuity and differentiability of this function at this point x is equal to 0, right? So let us first see the continuity of this function at this point, and then we'll see whether this function is derivable at x is equal to 0 or not. So let us start. So now to discuss the continuity of this function at x is equal to 0, we'll find out the right hand limit and then the left hand limit, and then the value of the function at this point, that is x is equal to 0. And then we'll see whether the right hand limit is equal to the left hand limit, and both these limits are equal to the value of the function at this point. So let us first find the right hand limit. So the notation for the right hand limit is limit, and here we have x tends to 0. Here we put a positive sign, and here we have f of x, right? So now here we'll take x is equal to 0 plus h, where h is a positive quantity, that is h is greater than 0. So we have when x tends to 0, then obviously h tends to 0. So now writing this limit in terms of h, that is x is equal to 0 plus h, that is h. We have limit for x tends to 0 positive, we can now write h tends to 0, and for f of x we can now write x is equal to 0 plus h, that is h. So now we have limit h tends to 0, and f of h can be obtained by replacing x by h in the function. So we have h cube, and here we have a signum of h, right? Okay, so now we have to evaluate this limit, that is h cube times signum of h. So now we can write this limit as limit h tends to 0, and here we have h cube, and then we have limit h tends to 0 signum of h, right? So here we have used this result, that is limit x tends to say a, and if we have the product of two functions, then this limit is given by limit x tends to a f of x, and then we multiply it with limit x tends to a g of x. Okay, so now here let us first define the signum function, and signum function is defined like this: signum of x is equal to positive 1 whenever x is greater than 0, signum of x is 0 when x is equal to 0, and minus 1 when x is less than 0. So now here this limit is simply a 0 cube, because taking h is equal to 0 over here, and then here this limit, that is limit h tends to 0, signum of h is equal to limit h tends to 0, and here we have 1, right? Because h is a positive quantity, and whenever x is greater than 0, then signum of x is equal to plus 1. So here signum of h has the value 1. So now this limit is independent of h, then we can now write here 0, and this is simply 1. So here we have a 0. So the right hand limit of this function at x is equal to 0 is equal to 0. So now let us find out the left hand limit. So the notation for left hand limit is limit, and here we have x tends to 0, and here we put a negative sign, and here we have f of x. So now here we'll take x is equal to 0 minus h, that is simply minus h, and when x tends to 0, from the left of x is equal to 0, then h tends to 0, and obviously h is a positive quantity, that is greater than 0. So now left hand limit can be written in terms of h as limit h tends to 0, and here we have f of minus h, x is minus h. Okay, so now we can write limit h tends to 0, f of minus h can be obtained by replacing x by minus h. So we have minus h cube, and here we have signum of minus h. So now here we have a limit h tends to 0. Minus h cube is simply minus h cube, and here we have signum of minus h. So now we can take this negative sign in front of a limit notation, and we have limit h tends to 0 h cube, and then we have limit h tends to 0 and signum of minus h, right? So here we have used this result. So now we have minus, here h tends to 0 gives us 0 cube, and here we have limit h tends to 0, and signum of minus h is equal to minus 1, because h is greater than 0, so minus h is less than 0. So when x is less than 0, then signum of x is equal to minus 1. So here we have minus h less than 0, so signum of minus h should be equal to minus 1. So now here we have 0, so this entire term is now 0, so this is equal to 0, right? Okay, so the left hand limit of this function when x approaches to 0 is also equal to 0. Now f of 0 is given by taking x is equal to 0 in the function. So we have a 0 cube and then signum of 0. So now this is 0 and signum of 0 is 0, because when x is equal to 0, then signum of 0 is equal to 0. So here we have 0. So now we see that the right hand limit is equal to 0, the left hand limit is also equal to 0, and the value of the function at x is equal to 0 is also equal to 0. So here the right hand limit is equal to the left hand limit, and this is further equal to the value of the function at x is equal to 0. So the condition for the continuity of a function at a given point in its domain is that the right hand limit and the left hand limit both should be finite, and they should exist, and they should be equal to each other, and moreover the both sided limit should be equal to the value of the function at the given point. So here we conclude that this function for this function right hand limit is equal to 0, left hand limit is equal to 0, and f of 0 is also equal to 0. So all these three quantities are equal to each other, hence this function is continuous at x is equal to 0. So now let us discuss the differentiability of this function at x is equal to 0. So for this we have to find out the left hand derivative and the right hand derivative of this function at x is equal to 0. And if right hand derivative and left hand derivative both exist and they are finite and they are equal to each other, then we can claim that this function f of x is differentiable at x is equal to 0. So let us first find out the right hand derivative. So the right hand derivative is defined by this limit, that is limit h tends to 0, and here we have f of a plus h minus f of a, and here we have h. So the right hand derivative of the function at some point x is equal to a is defined by this limit h tends to 0, f of a plus h minus f of a divided by h, and here the value of a is 0, and the notation for a right hand derivative is f prime, and here we have a, and here we put a positive sign. So now for a is equal to 0, we have here the limit, that is limit h tends to 0, and we have f of 0 plus h, and then we have f of 0 divided by h. So we have limit h tends to 0, and here we have f of h and f of 0 divided by h. So now we can write here f of h as h cube and signum of h. So replacing x by h. Okay, and here f of 0, as we have just calculated, f of 0 is equal to 0, and here we have h. So now we can simplify it, and we have h cube and signum of h divided by h, and here this h and this h get cancelled, and we have limit h tends to 0 and h square, and here we have signum of h, and remember h is greater than 0, that is h is a positive quantity, right? So when h is positive quantity, that is x is greater than 0, then signum of x is 1. So signum of uh, positive h, that is signum of h, or we can simply write it as h. So signum of h is equal to plus 1. So we have limit h tends to 0, h square times 1, and here the limit is now limit h tends to 0, h square. So this is 0 square, that is equal to 0. So the right hand derivative of this function at x is equal to 0 is equal to 0. So now let us find out the left hand derivative. So the notation for left hand derivative is f prime, and here we have a, and we put a negative sign over a, and this is the left hand derivative is defined by this limit h tends to 0. We have f of a minus h minus f of a divided by minus h. So here our a is 0, and this quantity h is greater than 0, or this is positive. So now taking a is equal to 0, we have limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. So this is limit h tends to 0, f of minus h, and f of 0 is equal to 0, and here we have minus h. So this is limit h tends to 0, and f of minus h can be obtained by replacing x by minus h. So we have minus h cube, and here we have signum of minus h, and here we have minus h. So now we can write limit h tends to 0, and minus h cube is minus h cube, and here signum of minus h, and here we have minus h. So now again from the definition, signum of minus h is equal to minus 1, because h is greater than 0, so minus h is less than 0. So this is a negative quantity, and whenever this x is less than 0 or negative, then signum of x takes the value minus 1. So now we have limit h tends to 0, and here minus and minus get cancelled, and we have h square, and signum of minus h is equal to minus 1. So we have minus limit h tends to 0 h square, and taking h is equal to 0, we have here equal to, this limit is equal to 0. So the left hand derivative of this function at x is equal to 0 is equal to 0. So now we see that the right hand derivative is it exists and it is finite and it is equal to 0, and the left hand derivative is also finite and it exists and it is equal to 0. So both the derivatives are finite and they are equal to each other. That is, right hand derivative is equal to the left hand derivative and it is equal to 0, right? So we can also write it as f prime. Here we have 0 plus, and here we have f prime and 0 minus, and both the derivatives are equal to 0. So we can now claim that this function is differentiable at x is equal to 0, because both sided derivatives they are finite and they exist and they are equal to each other.